So now we know that in case of circular motion, there is always acceleration of the body which acts along the radius and towards the center of the circle. We call that centripetal acceleration. Okay. So now see, if we consider this car which is moving on a circular road. So here we need a force which is acting along the radius and towards the center of the circle. Okay, towards the center of that circular track, we can say. So that force will provide the centripetal force which is required for the circular motion of the car. Okay, and now can you spot that force? Which will be that force in this case? Yeah, it is centripetal force, but it will be provided by some real force. Okay, this force which acts along the radius and towards center, it is known as centripetal force. So here it is provided by the frictional force, okay, between this track and tires of the car. How come? So now if friction was not there, then this car, it would have slide. Okay, and in what direction it would have slide? So it will slide away from the center. Okay, it will always slide away from the center. So it's the frictional force which keeps it held on the track. Okay, which doesn't let it slide away from the center, which doesn't let it skid. Okay, so centripetal force is provided by the frictional force. And now I want to find out the maximum speed of this car. Okay, I want to find out the maximum speed of this car. So we know the centripetal force is equal to what? Mv square upon r. So now centripetal force is equal to what? It is the frictional force. And for maximum safety speed, the for maximum safety speed, this centripetal force will be maximum. Okay. So centripetal force is FCP max. It's equal to maximum value or limiting value of frictional force, static frictional force. And therefore, now you have mv max square upon r. Mv square upon r is equal to mu multiplied by normal reaction. Okay, this is mu s multiplied by normal reaction. And then normal reaction is equal to mg because there is no movement in vertical direction. Okay, and this surface is horizontal, so normal reaction is mg. Okay, so then you can cancel out this m and m, so you get v square is equal to how much? Mu multiplied by this r will go on other side, mu into rg. So v is equal to how much? Square root of mu rg. Okay, maximum safety speed on a curved road is equal to square root of mu s into rg. Is this thing clear? Yes, no? So we need to remember this formula, and okay, we need to remember the formula, and more than that, we need to understand the origin of centripetal force. Okay, everywhere. For example, in case of you have a ball or a stone tied to a string and you move it in horizontal circle, where will the centripetal force come from? So I'm saying you have a stone tied to a string. Okay, you keep it in your hand and it moves like this. Okay, you are moving it like this. So where will the centripetal force come from? You need centripetal force. So yeah, but what will provide it? Tension in the string. Okay, will be provided by tension in the string. So T is equal to centripetal force. in case of Earth revolving around Sun, okay, what will provide the centripetal force? It is the gravitational force, right? It is the gravitational force, okay. Gravitational force is equal to centripetal force. Then in case of an electron revolving around the nucleus, okay, so this is suppose hydrogen atom, and this is a proton, this is electron revolving around the nucleus. Which thing will provide the centripetal force? So it will be Coulomb's force, okay, attractive force between this proton and electron, right? So FCP equals to the Coulomb's force, okay, electrostatic force of attraction. Okay, so we need to understand everywhere the origin of centripetal force. Okay, then let us see next topic, which is banking of roads. So what is banking of roads? So now what happens is, so suppose you have, for example, in hilly region, okay, the roads are circular and there are high chances that your vehicle will skid, and if it skids on hilly region, it will fall into the valley. Okay, so in order that not to happen, what do? We make banked roads. So what are banked roads? In case of banked roads, the outer edge of the road, it is inclined at some angle with respect to the inner edge. So you will see, if you go to some hill station, the roads there will be like this. The outer edge will be inclined with respect to the inner edge. So this thing is known as banking of roads. Okay, this thing is known as banking of roads. Okay, so why is it known as banking? So we can be rest assured, when we keep our money in bank, we are assured that it will not be stolen, right? So in this case, when we do this, what happens, that we can be assured that whatever speed limit is given after doing banking of roads, if we are under that limit, our vehicle will not skid. Okay, so let's see how much is that speed limit. So now there is a long derivation. We don't need it at this point, or shall I explain it? So we need to by heart this formula. So when we do bank, I'm sorry. Okay. So when we do banking of roads, this will be the formula. V is equal to, what is V? Vmax is the safety speed limit. The square root of Rg. R is radius of curvature of that road. G is or acceleration due to gravity. So it's square root of Rg multiplied by tan theta plus mu s, or you can say mu s plus tan theta divided by 1 minus mu s tan theta. Okay, mu s plus tan theta divided by 1 minus mu s tan theta. This is the formula. We need to remember this. Okay, and now even if mu s is 0, even if there is no friction, for example, when there is rain, okay, or some oil is sprayed on the surface, some oil is sprayed on the road. So now what might happen? Mu will not be same. The coefficient of friction will not be same. If oil is sprayed, so mu is almost 0, we can say. So there are great chances of skidding. But still, if we do banking of roads, even if mu is 0, put mu equals to 0 here. So what will you get? If you put mu equals to 0, it will be square root of Rg multiplied by tan of theta. Okay, so Vmax is equal to square root of Rg tan theta. This is the formula. Is it clear? Yes, no? Okay, so we have to remember this formula. as well as this one, right? Because in exam we'll not put mu equals to 0 in this formula and find out. Okay, all right. So let us see some questions based upon circular motion. The first one, a ball of mass 0.25 kg attached to the end of a string of length 1.96 meter is moving in horizontal circle. The string will break if the tension is more than 25 Newton. What is the maximum speed with which the ball can be moved? So, as I said, you have this ball. In this case, tension provides for the centripetal force. Okay. So FCP is equal to mv square upon r, right? And it is equal to what? It's equal to the tension T. Okay. So when T is maximum, V will be maximum, right? Because T is proportional to V square. So you can increase the speed till the time the tension reaches to the maximum limit. Okay. If you increase beyond that, it will break. Okay. So we don't want that to happen. So for that, we want to find out the maximum speed. So it is mv square divided by r. V square will be equal to what? T into r divided by m. So how much is T? It's 25. How much is r? R is length 1.96 meters and mass is 0.25. So 0.25 and this is 25. So this will be 100. 100 multiplied by 1.96. So they wanted to make it easy. That's why it is 196, right? And V will be square root of 196. That is 14 meters per second. Okay, so this was simple question. Okay, this is old question, but still this kind of question can be asked. This is not very simple. Okay, it's not like you can just tick it. You have to do some calculation, but it's very small. So simple question. Let's see next one. Car, a 500 kg car takes a round turn of radius 50 meter with a velocity of 36 kilometers per hour. The centripetal force is. So first of all, we have to convert this velocity. Right, right. So it will be 36 multiplied by 5 by 18. So this is 2 times 5 is 10 meters per second. Good. So we got speed and then you can just right. So centripetal force is mv square upon r. So 500 multiplied by 10 square divided by r is 50. So calculation is also simple. It's 10. 10 times 100 is 1000. Okay. All right. Next question. A roller coaster is designed such that riders experience weightlessness as they go round the top of the hill, whose radius of curvature is 20 meters. The speed of the car at the top of the hill is between. Okay. So now, why do we experience weightlessness? When we feel g is equal to 0. And why do we feel our weight? No, no, there is no. Okay. So see, now let's suppose this is me. I'm standing on the surface. Okay. I feel my weight because of the normal reaction exerted by the surface. Okay. I feel my weight because of the normal reaction exerted by the surface. So normal reaction is equal to N. Okay. Now my weight will be equal to the normal reaction. So now when you have a roller coaster ride, so in roller coaster, sometimes there will be upward curvature, sometimes there will be a downward curvature, right? Or concave curvature. So in case of curvature like this, what will happen? You have, suppose this person. So now see, it's moving like this. So you need to provide some centripetal force also, because this is like a part of a circle. So you need some centripetal force FCP. So your weight is acting downwards, okay? Mg is acting downwards and normal reaction is acting upwards. Normal reaction is acting upwards. So how much will be the centripetal force? It will be Mg minus N, because see, centripetal force is not, it is provided by some real forces. Okay, so its origin is this gravitational force and the normal reaction. Gravitational force is downwards, N is upwards, net downward force is the centripetal force. Okay, so it is Mg minus N. And when N is 0, because then only the person will feel weightless. Okay, so N is given to be 0, so this thing is 0. So FCP is equal to Mg, and therefore mv square upon r is equal to mg, you can say. Okay, gets cancelled out. You have v square equals to rg, and you want the speed when this thing happens. So r is 20, g is 10, so this is 200. So v square is equal to 200, so v will be equal to square root of 200. So this will be near about 14, right? Okay, so it is option C, 14 meters to 15 meters, because this will be slightly greater than 14. Okay, so is this thing clear? This was a good question. Okay, it's not like plug and play kind of question. You need to think a little bit in this question. So this is good. All right, let's see next one. A gramophone record is revolving with an angular velocity omega. Coin is placed at a distance r from the center of the record. The static coefficient of friction is mu. The coin will revolve with the record if. This is the question. So you have a gramophone record like this, and there is a coin. Okay, the record is revolving in a circle with angular velocity omega, and coin will also revolve. Okay, there is some friction between coin and record, and it is mu. Coin will also revolve when? This is the question. Okay. So see, it revolves in this circle. The centripetal force needed is provided by frictional force, right? Because record is moving, you have some motor to make it revolve. Okay, but that coin is moving along with the record, so it is also moving in circle. So for this coin to move, you need some force, centripetal force. It is provided by the frictional force. So till the time the velocity or the centripetal force required is less than this maximum value of frictional force, it will keep on revolving. After that, it will skid. Okay, yes, no, and we let's check. So FCP should be less than or equal to what? Frictional force. FCP is equal to m multiplied by r omega square. This is another formula. It is mass multiplied by centripetal acceleration. And we have three formulae for centripetal acceleration. We had seen, okay, one is v square upon r. So then the centripetal force becomes mv square upon r. Then you have one another formula r omega square. So in this case, centripetal force will become m multiplied by r omega square, right? And one is omega into v. So we are given with omega, we'll use this formula. So this is less than or equal to Fs, which is mu s into normal reaction. Mu multiplied by mg. Mm gets cancelled. Yes. So R is less than or equal to mu g upon omega square. This is the answer. Option C, you said, right? Okay. But there is one more option. Option G. Left and right side is equal. Sign is, okay. This is less than or equal to, this is greater than or equal to. So which one is correct? Less than only is correct. Okay. The FCP should be less than or equal to the frictional force, right? Not the other way around. Okay. All right. Next question. Car of mass m is moving on a level circular track of radius r. If mu s represents the static friction between the road and tires of the car, the maximum speed of the car in circular motion is given by. This is straightforward. It's option D. Next question. Car of mass 1000 kg negotiates a bank curve of radius 90 meter on a frictionless road. If the banking angle is 45 degrees, the speed of the car is. Tell me. V is equal to square root of Rg tan theta because it is frictionless. So it is 90 multiplied by 1000. No, not 1000. What is 1000? It's mass. It doesn't depend on mass. Okay, good. So there can be a question. Okay, that masses of two cars are 1000 kg and 1200 kgs. So the critical speed for these two cars, it will be greater for first car, it will be greater for second one, okay, or it will be equal. There can be a question like this also. So critical speed does not depend on mass. For all masses, it will be equal. Okay. So yeah, G is equal to 10. Then tan of theta, tan of 45 degrees, that is 1. So it is 900, square root of 900. Right. So it is 30 meters per second. This is a simple question. Next one. Car is moving in a circular horizontal track of radius 10 meter with a constant speed of 10 meters per second. A bob is suspended from the roof of the car by a light wire of length 1 meter. Angle made by the wire with the vertical is. Okay. So tell me, what should we do? There is a car which is moving in circle. Okay, circular track. So the car, suppose it's moving on the circle. Okay, car is like this. And there is a string. Okay, there is a wire. And a bob is suspended from that wire. Okay, from the roof by means of that wire. and it's given that it makes some angle. Why will it make any angle? Okay, what is the acceleration in car? Right. Car is performing circular motion. Centripetal force for that circular motion, it is provided by what? Friction. Now this bob is also providing, sorry, bob is also moving in a circle. So here we need centripetal force. Which thing will provide it? So see, when this becomes inclined, when this wire becomes inclined, what happens? There are two components of the tension in the wire. One will be the horizontal component and one will be vertical component. So if this angle is theta, suppose this angle is theta, then this will be t cos theta, this will be t sin theta, right? It makes an angle theta with the vertical. So here this t sin theta is in direction of the radius of the circle. So it provides the centripetal force. Okay, so we can say that t sin theta is equal to what? mv square upon r. And what about this other component? T cos theta will balance the weight of that bob. So T cos theta is equal to mg. And then we can divide this. So sin theta upon cos theta is tan of theta. It's equal to, you get gets cancelled, v square upon rg. And therefore now uh, theta will be equal to what? Tan inverse of v square upon rg. So what is v? 10. So it's 10 square. How much is r? R is 10. How much is g? Is 10. So it is 100 upon 100. 1. Tan of theta is 1. Therefore theta equals to 45 degrees. Right. So 45 means pi by 4. Okay. So now in this question we have solved this. Okay. In this question we have solved this. But there can be a lot of questions like this. Okay. So see, one is banking of roads. That angle is, okay, for that angle also tan of theta is v square upon rg. In this case also, if you have some vehicle, a bob is connected and a bob is connected to a string, vehicle is moving in a circle, then the string will get inclined. So that angle is suppose theta. So in that case also tan of theta will be equal to v square upon rg. Then there can be a question, a cyclist is there, cyclist is taking a turn. Okay, so he bends. So he bends to provide himself some centripetal force. So by what angle will he bend? So in that case also tan of theta will be equal to v square upon rg. So remember this, in case of a circular motion, if you have some inclination or some bending, always tan of theta, angle with the vertical, okay, will be equal to what? Will be v square upon rg. Yes, no? Okay. But in case of banking of roads, that angle is with the horizontal. Okay. In case of banking of roads, the angle is with horizontal. Now, in this case, what's happening? The system is providing itself some centripetal force. In this case, what's happening? This string gets inclined. In case of cyclist taking a turn, the cyclist gets inclined. Okay. In case of banking of roads, we are giving already some inclination. Okay. So there is difference in those cases. But see, whenever this angle is asked, okay, apart from banking of roads, whenever you have suppose some inclination and circular motion, so inclination with respect to vertical, is suppose theta, you have tan of theta equals to v square upon rg. If they ask inclination with respect to horizontal, then it will be cot of theta. Okay, yes or no? So we should remember this, and uh, even if we don't remember, it will not take more than 1 minute. But if we remember it, then it will be very quick. Okay, tan theta equals to v square upon rg. All right, let's see next question. Two stones of masses m and 2m are whirled in horizontal circles. The heavier one in a radius r by 2 and lighter one in radius r. Tangential speed of lighter stone is n times that of the value of heavier stone when they experience same centripetal forces. The values of n is value of n is this is the question. So this is simple question, right? Let's call r1 equals to r by 2, r2 is equal to how much? It's r, and masses are m1 and m2. m1 is m, m2 is 2m, and tangential speed of lighter stone is n times. Okay, no, this is actually heavier one has radius r by 2, and okay, so m1 is 2m I can say, and m2 is m, because heavier one has radius r by 2. So the tangential speed of lighter stone is n times that of the value of heavier stone. This is given. Okay, when they experience same centripetal force. So you have tangential speed of lighter stone is n times. So you can say m1 v1 square upon r1 is equal to m2 v2 square upon r2, because centripetal force is equal. Okay, and the tangential speed of lighter stone is n times. So which one is lighter? Second one is lighter. Okay, so v2 is equal to n times v, or n times v1. So you have m2, which is m multiplied by n times v1 square divided by, now let's put the values. So this is m1 v1 square, and m1 is equal to 2m, r1 is equal to what? r r by 2, sorry, r by 2, and r2 is equal to r. So this thing gets cancelled, m r v1 square gets cancelled. You have n square on that side, so n square is equal to 4 you get, right, because this 2 will go to numerator, and therefore n is equal to 2. Okay, simple, yes, no? All right, let's see next question. A car is negotiating a curved road of radius r. The road is banked at an angle theta. Coefficient of friction between the tires of a car and road is mu s. The maximum safe speed on this road is. So this is direct question. It is option D, right? So it is square root of mu into r. Sorry, if it is frictionless, if it is with no banking, then square root of mu rg. If there is banking, then rg will be there in numerator. This factor is in multiplication. Okay, so this is simple. Let's see next question. One end of a one end of string of length L is connected to a particle of mass m and other end is connected to small peg on a smooth horizontal table. If the particle moves in circle with speed v, the net force on the particle is, okay, net force on the particle directed towards center will be, T represents the tension in the string. Tell me. Okay. So this is smooth horizontal table. That means there is not going to be any frictional force. Okay. So you have a peg like this. You connect a string and there is a particle which is connected to it. It's moving in a circle. It's moving in this circle. Okay. So how much is the force on this? Only tension, right? What else is there? Why are you adding mv square upon L? It's okay, no problem. So T will be equal to mv square upon L, right? This mv square upon L or the centripetal force, it is provided by T. Okay. So it is not force in itself. It is provided by some other force, right? We need to remember this. It is provided by T. It comes because of T. Yes, no? Okay. Is it clear? Okay. So this is straightforward question. Let's see next one. A block of mass 10 kg is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. The coefficient of friction between the block and the inner wall of the cylinder is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about the axis will be. Okay, so you have a cylinder, it's rotating, and you keep a block here in contact with the wall. Okay, if it is not rotating, block will fall down. Okay, so now see, there will be some frictional force. So frictional force will act upwards because we don't want it to fall down. So frictional force Fs is upwards and the gravitational force is acting in downwards direction. It's mg. Okay, if it is not falling down, means Fs is equal to mg. It is not sliding from that surface. So Fs will be equal to mu into normal reaction. What is normal reaction? In what direction will it be? Along normal direction, normal to the surface. Okay. So now in this case, when it rotates, the centripetal force is provided by the normal reaction. Okay. When it rotates, the centripetal force will be provided by the normal reaction. So you can say this is mu s into n is equal to mg. So how much will be the normal reaction? It will be equal to mv square upon r. V is given or what is given? It rotates. What is asked? Angular velocity. Okay. So we'll use this formula. N is equal to centripetal force, but this formula mr omega square. Okay. So let's substitute that here. So we get mu s multiplied by mr omega square is equal to mg. Gets cancelled, right? So omega square is equal to g upon mu r. Okay, and that is 10 divided by mu is how much? 0.1. R is how much? It's 1. So this is 100, right? 10 divided by 0.1, it's 100. Option D, right? So omega equals to 10. Okay, option D. This is clear? Yes, no?